absolute value, you have this integral, and the tangents cancel out then, right? So you've got the integral of secant, which is its own little problem, but it's yeah, never mind, right? It's next year. Okay.
Was that question?
So 91, 104. Well, when we get to the end, we should probably slow down and smell the roses a little bit. So how about they've got a couple of hybrid functions, like yeah, 104 is actually would be a multiple of 13, huh? Sure. Proving more identities. Can't wait. Here it comes. So the sixth power of sine beta plus the sixth power of cosine beta is apparently 1 minus 3 times, really? So sine to the sixth power of beta, well, sine of beta to the sixth power plus cosine of beta to the sixth power is apparently, so this is an identity, 1 minus sine, 3 sine squared? Yeah, sine squared, cosine squared. Okay. Well, we could put this on the big screen. So this would be, do you know about Word? If you're ever needing to write a scientific article, you should probably use LaTeX, but short of LaTeX, there's the equation editor. So you get the equation editor in Word by doing Alt equals. It brings up the equation editor. And so I want to type in here, I think I got to say sine like that of beta like this, and oh, I guess it doesn't like that. See, it's not quite LaTeX, is it? No, so how do you get the sine? All right, so let me just type in sine. Yeah, see, if you say sine of, then it recognizes that that's sine. And we can say beta like that. Yeah, so then we'll get a beta. Okay. We want to say to the sixth power. And we want to make this larger. Oh, crap. Of beta again. I'm just going to delete that other beta. Okay. Can we make this larger? There. Now it's visible to all. And so how about plus cosine? So I'm going to write cosine to the sixth power, space. Right, so then it recognizes I've got something I can fill in here. And backslash beta will get you the Greek letter beta. And so we want to show that that's equal to 1 minus 3 times, yeah, so sine to the second power, space bar, open parentheses, beta. Okay, and then cosine to the second power. Okay, so here it is, right? What are we going to do? Well, you can factor 6 powers, can't you? You can factor that in 2 ways. So let's think about what those 2 ways are. I'll do a little sidebar here. So we have a cubed plus b cubed. That's equal to a plus, remember this? A squared minus ab plus b squared. That's the sum of cubes. So would that be handy here? So if we have a to the 6th plus b to the 6th, that's going to be the square of, sorry, the cube of a squared, right? So I can think of that as a squared cubed plus b squared cubed, right? And so I would just replace a with a squared and b with b squared. then here this is gonna be a to the fourth, the square of a squared, minus a squared b squared,
B.
plus b to the fourth. Right, so for the left side, I can say, look, a is sine beta, and so I'm gonna have sine squared beta, and b is cosine beta
Squared.
squared, so this is gonna be, yeah, so when I factor it, so I'm gonna do shift enter here, and I'll get in parentheses now, sine, whoops, sorry, sine squared of beta. I'm gonna write this in even though it's obvious what that is, right?
Plus
Plus,
cosine.
oh, plus, I think I kinda want, yeah, plus
Cosine.
cosine squared beta times, what do we got?
You didn't close the other one. You needed a
Your starting bracket before
Oh,
sine.
yeah, good call.
Sine.
That's a different kind of radar.
Oh.
Parentheses radar.
Parentheses.
Pythagoras radar, parentheses radar, it's all kinds of radars you gotta have working. So what is this next one? It's to the fourth power? Okay, so it's gonna be sine to the fourth power of beta? No, what's that character? I don't know what I said. Okay, and that's then minus the product of
Two.
cosine, oh, do we care if it's cosine, sine? Let's put sine first. Sine squared beta cosine squared beta. I think we have to zoom out a bit here, huh? And then plus cosine to the fourth, oh, just cosine, right? Beta. And close parentheses.
I'm missing like what is it? 9.
So that's just the left side. What do you have to, what?
The 3.
Oh,
Is that-
yeah, so what about
Number
the three?
Yeah.
Oh, well, yeah, I don't have any three yet. Somehow-
It's in the main. In the top one.
Yeah, I don't have the right-hand side at all yet.
Oh, I just realized that.
Yeah, this is
You're
just
right.
the left side, right?
You're right. Yep.
So let's just work with the left side. See, and so now this is just one, right? Cosine squared to sine squared, so that's a good thing. And so let's just recopy, because I don't have space for the right side. Oh, wow, that was fast. So I'm gonna say copy, whoops. Yeah, copy that. So this equals this, right? So maybe I should say it's equal to, it's just the left side, right?
Yes.
So I'm just working with the left side. And what have I got? I've got a sum of fourth powers. Can I do anything with that? No, I can't factor a sum of squares. I suppose I could factor out sine squared.
No.
From the first two.
Yeah.
Or I could replace sine squared with 1 minus cosine squared.
We could group them.
Yeah, let's do that. Yeah, grouping, but yeah, watch what happens here. I mean, there's probably a lot of different ways of getting this, but man, it's fast. So I'm gonna go like this, copy it, what we've got. Then this little bit here, I'm gonna erase that and say I've got in parentheses 1 minus this thing. You see how I can do that? So I'm simply replacing sine squared beta with 1 minus cosine squared beta. Is that a good idea?
Yes, it is. Or is it?
I don't know. We could expand and see what happens. We want to end up, and we keep an idea, an eye on the prize, we want to end up with cosine squared times sine squared. I don't necessarily see that happening yet, but I do see that if I copy this, I can edit it without having to do so much typing, right? And I can then say, well, if I distribute that factor cosine squared, I get this, right? And I don't have this parenthesis anymore. And those last two terms cancel out, right? You see what's happening here?
Yes.
All right. So now I just have sine to the fourth minus cosine squared, which I don't see that that's really going to get me where I want to go.